Assalamualaikum warahmatullahi wabarakatuh. Good morning, honorable judges, committee, audience, and participants of MOA Presentasi and 13. Thanks for this incredible time for me. First of all, I would like to introduce myself. My name is Pratama, and I am a student of Petroleum Engineering Department, Universitas Pemandu Nasional Veteran Yogyakarta. In this event, I would like to present my paper with title Utilization of Natural Zeolite Cladded as a Nanotechnology for Produced Water Treatment from Dewatering Coalbed Method or CBM to Prevent Environmental Contamination. And then this is the outline in this presentation, where in this outline I divided into 6 main points. First, introduction; second, overview; third, methodology; fourth, presentation; fifth, conclusion; and the last, recommendation. First, about introduction. The background why I choose this topic because of Indonesia's reach of CBM resources. Based on Evaluations International 2003, estimated CBM resources in Indonesia is about 453 TCF, and one of the countries that has the largest potential CBM in the world. In the beginning of producing CBM, I will start by the watering process, that is drainage of water from coalbed metal reservoir flowing to surface. And this process will result produce water in a large volume. So we need to treatment it before discharge to environment or use again, because CBM produced water can cause negative impact for environment and also for human health. One of alternative solutions to treatment CBM produced water by using zeolite, because zeolite has accessibility and Indonesia rich of zeolite resources. So based on this background, my purpose is to do this research first to analyze the characteristics of cladded natural zeolite used as a material, and the second one to design and create an environmental friendly technology for management of CBM produced water by using zeolite as by nanotechnology. And the last one is to prove that the utilization of zeolite as a nanotechnology can be used to filter out CBM produced water for obtaining water suitable with environmental quality standard. And then we are going to overview first about coalbed method or CBM reservoir. CBM has dual porosity system. They are cleat or fracture and also matrix. And gas mechanism can be stored in cleat or fracture and also in matrix, depending on the condition CBM reservoir itself. The condition of CBM reservoir is illustrated on Lamuir isotherm curve, where Lamuir isotherm curve is a plot of gas content versus pressure. If the plot of gas content versus pressure above on the curve, the condition of CBM reservoir is in saturated condition. But if the plot of below on the curve, the condition of CBM reservoir is in undersaturated condition. So we need to decrease pressure by doing the watering process. So in the beginning of producing CBM, I will start by producing water and make it different with conventional gas production. And then overview about zeolite. The vacuum volume of zeolite is large enough, sometimes reaching 50 angstrom, while the diameter of vacuum space is ranging from 2 angstrom to more than 8 angstrom, depending on the type of zeolite mineral. The volume and diameter of vacuum space are the basic for the use of zeolite mineral as a molecular filter or molecular sieving. So based on this theory, zeolite is belong to nanomaterials and can be used as a nanotechnology. And then what is nanotechnology about? Nanotechnology is defined as the ability to visualize, analyze, and manipulate materials on molecular scale of 0.1 to 100 nanometers. And then we are going to methodology. First about the population and sample. The produced water that used in this study by creating artificial produced water based on the actual characteristic of CBM produced water. And then the zeolite that used in this study was taken from Kedangsari, Western Jiwo, Bayat, Klaten, Central Java. And then this is the prototype we designed based on laboratory scale, which is shaped like a cylinder, and the inside is filled some kind of material as a filter of CBM produced water. First is silica sand, zeolite, and the last is gravel. And then this is the research diagram in this study, start from study literature, and then prepare the material and equipment consist of artificial produced water, where we do chemical analysis, and then the zeolite we do petrographic analysis and sieve analysis, and then for the silica then we use sandmerasi. Of course we do heating and screening process, and then the prototype, and then treatment or testing produced water by using the prototype, where we measure 4 parameters here. First is sodium-potassium ratio, total dissolved solid, total suspended solid, and the last is potential hydrogen. And then analysis data, making report, guidance, presentation, and finish. And then we are going to result on discussion first about the type of zeolite. Based on petrographic analysis, both sample 1 and sample 2 are obtained. The zeolite is belong to sedimentary plutonic, and the composition of zeolite minerals are 90% clay, 5% quartz, and 5% microlith plagioclase. So based on this result, the zeolite is belong to modernist type, which has a ratio of silica alumina relatively low, that is about 2.8. It means that the zeolite has a relatively high polar or hydrophilic, and then the cation exchange capacity is 2.29 ml equivalent per gram. It means that the zeolite can bind the compound or particle that has positive ions. And then the characteristic of CBN produced water. This is the initial data of CBN produced water before we treatment by using the prototype, and after treatment by using the prototype, we got all of the parameters here: sodium potassium ratio, total dissolved solid, total suspended solid, except potential hydrogen or decreases. And this result has passed the water quality standard from Environmental Minister Regulation number 2, 2011. And then this is the comparison between produced water before and after treatment, where we can see here the filtered water clearer than the initial CBN produced water. And then we discuss about the parameters as a part. First, about the sodium potassium ratio, where the prototype can reduce sodium potassium ratio of 49% from the initial sodium potassium ratio. And the material which contributes to decrease this content is zeolite, because zeolite is an anionic compound, so it can bind cationic compounds such as sodium, calcium, and magnesium. And then this is the test result of this total dissolved solid, or TDS, where the prototype can reduce total dissolved solid of 63% from the initial TDS. And this result is proportional with the test result of total suspended solid, where the prototype can reduce total suspended solid, or TSS, of 75% from the initial TSS. And the material which contributes to decrease this content is silication and zeolite, where the bigger particle will be screened by silication and smaller particle will be screened by the zeolite. So based on this result, we can conclude that first, CBN produced water treatment is very important to do, because produced water can cause negative impact for environment and human health. And the second one, based on petrographic analysis, natural zeolite from Klaten is belong to modernist type, which is containing 90% clay or momorylonite, 5% quartz, and 5% microlith plagioclase. And the third one, based on test result of chemistry laboratory analysis, the prototype can reduce sodium potassium ratio of 49% from the initial sodium potassium ratio produced water. And the fourth is, based on the test result of hydrology and water quality standard laboratory, the prototype can reduce total dissolved solid, or TDS, and total suspended solid, or TSS, respectively of 63% and 75% from the initial TDS and TSS CBN produced water. And the last, the utilization of zeolite as a nanotechnology is very perfect for management of CBN produced water, because it can prevent negative impact for environment and also for human health. And the filtered water can be used for community needs and the industry. And for recommendation, we also recommend that first, zeolite as a nanotechnology could be applied to filter or purify CBN produced water, because this technology is effective and efficient to decrease the percentage sum of constituent in CBN produced water, which potential to bother environment, such as sodium potassium ratio, total dissolved solid, and total suspended solid. And need advanced study to develop this technology, especially to determine the lifetime of zeolite. And then this is the references that is used in this study, and thank you.